Okay, now we can finally do the double linked list. Jeez. Alright, my neighbor's really going to town with that weed whacker or something. That's definitely getting in the sound. Oh well. So yeah, we're doing double linked list now. Go watch my single linked list if you have it. Yeah, so basically the only thing that changes with the double is it has another reference node, and that's the previous reference node. So this is what it looks like in code, the structure right here. We have this extra node here that references a previous field. So this is what it looks like visually, and this is what it looks like in the code. I'm actually going to copy this right here because we're going to need it when we design our linked list. So we have to design and implement a linked list and basically create all these methods and a structure for the linked list. So here's my double linked list. Alright. Sorry, I don't really like how that formatted. Okay. And actually, I'm going to rename it to list node class because it's just a lot easier to type. So yeah, got that there. And then we're going to need two instance variables, size and head. Okay. Then this is irrelevant. Now let's write this method here. So we need to get back the value of the index to the node in the linked list, and it's 0 index. And if it's invalid, then return -1. So let's first check to see if the index is valid. Geez, I got planes, I got generators, I got neighbors going to town. What are you looking for? No. Alright. If index is greater than or equal to size, then return -1. Otherwise, we are going to need to perform the operation. So basically, you need to create a list node called cur_head that references head, and then iterate over it. What am I doing here? To the index. So index times we need to do this operation. And what this line does right here is it just moves us forward in the linked list so we get to the point where we need to be. So now we should be able to just return cur_head.val. And yep, that's all good there. So now we're adding nodes. Okay, so this is what the add operation looks like visually. You have this cur node and you're setting that one's reference fields, but that's kind of irrelevant right now because we have a special case adding at the head. So that's the code I wrote earlier. Yeah. So now we got to add it at the head. So this is a special case. If the size is equal to 0, then we're just gonna set. Well, first let me create a list node cur equal to a new list node with the value that's passed into this method. And if the size is equal to 0, then just set head equal to cur because head references nothing, nil at that point. Otherwise, we're going to set cur.next equal to head, and then head.previous equal to cur, and then finally set head equal to cur. So what that does right there is we set the next field of cur equal to head. So we're adding on there, and then we have to set the previous. Make sure you set the previous. Otherwise it's nothing new. This is literally the only new line. And then just set head equal to cur, and make sure to increment our size variable. And whoa, we're all done there. So now another special case for adding, add at the tail. So let's create another list node cur. Bada bing, bada boom. And then once again, check if the size is equal to 0. I know this code is not very dry, but it's just easier to see if I write it all out. And then we're just going to set head equal to cur because that technically is the tail. So that's the special case we have to worry about for that. And then otherwise, adding at the tail, we're going to need to set create another list node, cur_head. Whoops. Set that equal to head. And then while cur_head.next, make sure it's .next is not equal to null because we never actually want cur_head to equal null, so we're checking its next field. So we want to stop right before it equals null. So that's why we're doing the next. So cur_head is equal to cur_head dot cur.next. Again, we're just iterating through the list. And at this point, then we're setting cur.head.next equal to cur.previous equal to cur.head. And yeah, that's all you have to do for that. Oh, and increase the size. So yep, basically this is the same as our other operation for the single linked list. We just have to add that previous little nugget in there. So now this one's a little harder. We're doing add at any index. Sorry, there was something on my keyboard. So we're adding a node. Let's first worry about, okay, if the index is greater than the length. I call it size. Then just return, as it says there. And then if index is equal to size, we have to do a special thing. What does it say to do? Oh, append it to the end. Well, good thing I already have a method to do that. Thank you very much. Oopsies. Tail, not head. Tail val. So just pass that in, and yep, don't even have to worry about that. And then another special case would be if the index is equal to 0. Oh, well, guess what we have for that? We can add it at the head. Nice. So those methods really came in handy. And then otherwise, we're going to have to do this little operation here. Add it before, keyword before the index. So let's create our cur.head. Set that equal to head, and then also we need cur equal to new node val. So we have that going for us, and now we're going to iterate through, but we want to be, remember, one before the we want to insert this before the index. So we're actually going to be doing index -1, so that will get us right before it, so that we can insert it properly. So we just need to iterate through cur.head as needed by the logic in this loop, and then once we're at this point, okay, this is where it gets, we need to go back to our graphic here. So we have got cur here. So first thing I'm going to do is just take it piece by piece. We're going to set cur's next equal to the next one that we want in the how we want it to be in the list, and then it's previous to the cur.head. So let's see what that looks like in the code. Okay. So cur.next is equal to cur.head.next, and that is I'm not going to click over because I got to scroll again. And cur.previous is equal to cur.head. So right there, what I've done, that first line is this right here, this little blue guy connecting to the next, and then the cur.head previous there. So this is all linked up here. Now we just got to change this blue arrow and this green arrow. So this is still our cur.head. So we're going to set cur.next.previous, the green arrow, equal to cur. That might not have made sense, but in code, basically I'm just moving that green arrow onto there. And then cur.head.next equals to cur. So let me write that out, just like I said in pseudocode. So cur, I forgot what I was doing. Okay, yeah, cur.next.previous is equal to cur, and then cur.head.next is equal to cur. And gonna make sure to increment the size. Don't want it to be outside. Make sure it's in the else loop, because these are gonna, otherwise you'll be adding it twice because of these methods, because those have adders, incrementers. I don't know what the heck they call them. Yeah. So now we're doing deleting. So first let's check if the index is valid. If index is greater than or equal to size, then it is not valid and we will return. Otherwise, we need to check if index is equal to 0. Then we need to do some stuff here. We need to set head equal to head.next, and then check if head is not equal to null, then set head.previous equal to null. The reason I have to do that little input validation there is to guard against a null pointer exception, because if there was only one thing in the list, then we'd be trying to set a previous reference field of null, and null has no previous. So yeah, that's what I'm doing there. And then otherwise, we need to delete the indexed node in the linked list. So list node cur head is equal to head, and then for, let's just do our little iteration here, is less than index -1 again, because for the delete operation you want to be 1 before, so we want to reference this because remember we do the little bypasser, and the only difference here is we just got to worry about this previous field. It's the same kind of thing with the single linked list. So worry about the bypasser here in a second. Okay, and then so we just need to see if we got to do a little bit more validation. Cur head.next is equal to null. Then we don't have to do, we've reached the end of the list basically. We're deleting the last element in the list. So all we got to do is set cur head.next equal to null. And then we're all good there. But otherwise, excuse me, then we're going to do our actual delete operation, which is to first set cur, spelling is hard, cur.next equal to, dude, they need to get some new names for these, cur head.next. So what that line does there is it just sets this next value equal to the one that's 15 value. So we've got this blue guy now going to reference that. And now we just got to do the same thing basically for the previous. So now we can just take, forgot a semicolon, cur head.next, and the reason we can do next is because we just changed that value. Dot previous, nope, that's not what we want. Wait, is it? Yes, it is. That previous is equal to cur head. That should work. And then the size. So I think we want that to be outside of the loop. Yeah, we do, because it needs to iterate for both of those. Okay, so this is looking pretty nice. I'm very proud of this. Let's run it, check for syntax errors. Oh, judging it, so it worked pretty well there. And yep, okay, submit this. There's so many test cases. It took me so long to get them all to pass. Please, 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 please. Yes, okay, accepted. Finally. Alright. I'm gonna go eat Chick-fil-A sandwich because I got one waiting for me. And, yep. Good stuff.